Good evening, everyone. So we will continue. So, today we will continue with the AI robotics. Yesterday we have seen some part about AI robotics, artificial intelligence and robotics. So today we will continue from there, and today we'll see some practical examples and we'll talk about Jetson Nano board that we will be using. So in yesterday's class, we have seen that we can use we have discussed that we can use when it comes to AI, artificial intelligence based robotic projects. We can use boards like Jetson Nano. So Jetson Nano is a single board computer. So it's called an SBC, single board computer. So it's very similar to other boards like Edison board or Beaglebone or Raspberry Pi, like Raspberry Pi 4. So there are so this one is this the image you can see here. This one is a kit, development kit from Jetson Nano. So this kit has all the like peripherals and connectivity and the cooling system, everything inbuilt. The cooling system means this is just a heat sink, everything inbuilt. And you can also connect fan here, and there is option for fan connectivity here. You can connect fans like cooling fan here. So you can set it up like a normal desktop, or you can buy a bare metal like a basic Jetson where that you will be using in some product. So in case of a product, you don't need all these connectivity and all these like this is very bulky when we are considering a compact product. So in that case, all we need is just single PCB, and we can make our custom board with that PCB. So that if you are developing a product based on that, then you can use that. Otherwise, if you are just trying to make a prototype, then you can use this board because it is easier than using the other option. So Jetson Nano board. So I'm using a Jetson Nano board here. So before going into that, we will just discuss about the board itself. So Jetson Nano dev kits. So it is called Jetson Nano dev kit, and this particular model is a 4 GB version. So if you take Jetson Nano, there are two variants in Jetson Nano, one with the 4 GB RAM and another one with the 2 GB RAM. So 2 GB RAM one is actually less costly, and so with the 4 GB RAM, Jetson Nano we can do so many different type of projects. And there are other type of Jetson boards are also there. Jetson Tegra, this type of Savior, this type of different boards are there. So these are more powerful and costly boards. Like if you take Jetson Nano 4 GB version, if it costs 22,000, like 14,000 to 22,000. And Tegra and all those other high-end models will cost like 40,000 to 40,000 in that range. So our expense, like our prototyping expense, will increase. So if you want to make a small, like medium level kind of prototype, then you can use the Jetson Nano 4 GB version, which is much more powerful than using a Raspberry Pi or a Beaglebone. So CPU, like this is just the specification of Jetson Nano. So CPU is a 64-bit quad-core ARM A57 with the 1.43 GHz working CPU frequency. So it's a 64-bit system. It's a 64-bit computer with the ARM. So it is not based on 86 architecture. It is based on ARM architecture. So it has an SoC, ARM-based SoC, ARM-based SoC from NVIDIA. So the SoC is a quad-core 64-bit CPU. Quad-core 64-bit CPU. It can work at 1.43 gigahertz frequency. And then GPU 128 core NVIDIA Maxwell GPU with the 921 megahertz frequency, working frequency of 921 megahertz. So it's a 128 core for NVIDIA Maxwell GPU. GPU and CPU both are inbuilt in the board. And then memory, there is a 4 GB, 4 GB RAM. So 4 GB 64 LP DDR4 at 1600 megahertz and 25.6 GB per second. This is the specification of the internal memory, the RAM memory. The RAM memory just an 4 GB variant, and then video encoder and video decoders, then USB connectivity. So you can see that we have like 4 different USB ports here. So USB 3.A, sorry 3.0A, and USB 2.0 micro B. So there is you can see here on the side of this one. Here this is a USB B B type, micro B type. So this one is normal USB 3.0. And so using this USB here, we can, so these 4 USBs are just for data transfer, or connecting like different type of devices like camera or sensors with the USB interface. And this one here is for power. So we have 2 options here for power. Either you can use this barrel connector. So this barrel connector is for connecting 5-volt power supply, 5-volt power supply, and this one is also can be used for connecting power supply. You can use a normal power adapter, and using the power adapter you can easily connect the power supply. Here. So also you can connect this to your system, and you can get a serial interface. So for example, when you're connecting a normal board like a single board computer, you need to have some essentials. So right now, I'll just share a video of my board. So this is the board that I'm using here. This is a Jetson Nano board I'm using. So this is not the same board I'm talking about right now. This is a 2 GB variant. So this is a 2 GB variant, and it has all the same kind of connectivity like the 4 GB variant, but there is small difference. Like instead of the barrel connector, we have a C-type connector here. So this one is a C-type connector, and this is used for power. So on the other side, there is a micro B USB, but this one is not for power supply. This one is only for data communication. So any output communication from Jetson Nano we can get from this one here. And then there are 3 normal USB ports. 3 normal USB ports that you can use for data transfer. Then there is a LAN connector, and there is an HDMI connector. So this is basically, you can say this is a CPU. So to use the CPU, we need, like any other CPU, we need a monitor. Like any other CPU, we need a monitor and a keyboard mouse. So we can connect the monitor to HDMI port, and you can connect the keyboard and mouse to USB connectors. So these are 3 essential things you need. You need to have to get started with the Jetson or any kind of central board computer. But in case if you don't have these essential, then you have another option to communicate with the Jetson Nano. You can use this USB port here. So this USB port is output from Jetson Nano. So Jetson Nano has serial UART. So this USB port will give access to a COM port of Jetson Nano, COM port in Jetson Nano, communication port to Jetson Nano. So if we can access through that communication port, we can access a terminal. So you can use like softwares like serial monitor software, different type of serial number software, or you can use a cookie software to get access to Jetson Nano. So if you connect to that phone port in your laptop, you can access Jetson Nano terminal. So it's a Linux OS. We'll see that. So it's a Linux OS. So that means you can just type commands, connect to a network, or run things or install packages. Then afterwards, you can connect it using a remote desktop application. So we can have a full desktop view instead of just having a terminal view. Terminal view usage is very limited. We can only have run certain commands and execute certain things. So it is much more easier to use a full UI interface, full desktop UI interface. So to get that, you can use some kind of remote connection application. So I'm using this software called VNC, virtual network connection. So VNC viewer, using the VNC viewer, I'm accessing the Jetson OS through my Windows OS. So then networking, so there is an LLM, and there is no Wi-Fi, inbuilt Wi-Fi, so that's why we have to use USB Wi-Fi dongles to get a connectivity. So I'm using this Wi-Fi dongle here or to connect to Wi-Fi network. So why we need to connect to network means we need to connect with the remote network, remote connection. To make the remote connection, we need a network, like a common network. So it should be a Wi-Fi network or Ethernet. So Wi-Fi is easy to use. I'm using Wi-Fi network. Then storage, micro SD card, 40-pin headers. So 40-pin headers includes all these things, like all these peripherals like UART, SP, I2C, I2S. So all these are like normal, like peripherals of a normal microcontroller. Any kind of modern microcontroller will have all these peripherals. Like if you take any type of ARM microcontroller or Pico, area, or other type of microcontroller, or whether it is NSC ports or DNS ports, all those different type of controllers will have all these different peripherals, communication peripherals. These are your serial communication, SPA, so serial communication, I2C serial communication, and I2C is audio communication for using serial, and audio for GPIO. So GPIO means general purpose input output. We can connect like basic actuators and sensor, basic simple actuators and sensors using this GPIO connection. Then there is 5-volt power supply, input power supply, and so you have multiple options. Micro USB. So in case of 4GB variant, you can use micro USB or barrel jack or power through Ethernet. So that is something we can use. Like we can power up the Raspberry Pi or the Jetson Nano using Ethernet. So you need a separate hardware for that. Also 5 watts, 10 watt connection. You can select options between 5 watt, high power or low power mode. Then size of the board is 80 by 100. So it's a very compact board. You can hold it in your hand. It's very small, and so it's easy to make. So easy to prototype small or large scale robotic systems using Jetson and distributors. Different distributors are these. That Jetson Nano compact AI computing group. So this is the one I was talking about. This is the board I was talking about, which is same as the Jetson Nano that we can see here, but this is just the PCB here instead of the whole board. It is just a PCB. It's just a PCB instead of the whole TPI. So you can use this for developing your own applications, like custom applications, where you can add this to your whole board. So Jetson Nano compact AI compute module 122.4. So the same specifications as the dev kit. So it will be 60 GB eMMC, and the size is much more compact. So you can see size is much more compact than the dev kit, and everything else is the same as the dev kit. But the connectivity, we don't have the same kind of connectivity here. You have to make it yourself. Then Jetson family from AI at the edge of autonomous machines. So these are the different kind of Jetson boards available. One of the most basic one is Jetson Nano. So then Jetson TX1 and TX2. So this is the other variant, just one that is above Jetson Nano. And then Jetson TX2 8 GB variant. There is an industrial model, 8 GB variant. And then Jetson AGX Savior, that is also can be used for high-end applications. So these are like 4 examples. So then system setup. So how to set up the Jetson Nano, so we can device booted from micro SD card. So it is so like in case of any single board computer, we need a micro SD card to write the operating system. So this whole thing is working based on an operating system, So we can so the NVIDIA itself provides images like SD card images. Images means SD card operating system images for Jetson Nano. So it's called Jetpack. The OS is called Jetpack. You can download that for free from Jetson NVIDIA.com, and then you can write that OS to a SD card, a micro SD card. So the micro SD card should be minimum 16 GB. Because the OS itself is 7 GB, 8 GB, and once you write, you need some space for your system, like whether you're going to save some files or videos or data sets or whatever it is, you should have some extra space. Or if you want to install extra packages, like some packages, most of the packages that we use in deep learning, like PyTorch or OpenCV or Keras, all these things are not inbuilt in Jetpack OS. So we have to install all those things externally, manually. So it will take some. So for that we need some space, and also we need to allocate some swap memory, because while we are building different type of packages, the inbuilt RAM may not be enough. While we are building, not for like normal purposes, while we are building. Building is a heavy process which needs a lot of memory. Also CPU power and also memory. So CPU will be working with 100% while building like high-end packages like PyTorch, like otherwise ROS, different type of ROS packages or OpenCV. You need a lot of memory, and the CPU need to be allocated. CPU need to be using full of its resources, all of its resources. That means then in most cases, you need extra memory. The 4 GB or 2 GB RAM you have may not be enough. So in that case, you can create swap RAM space. That means you can use your SD card memory as a RAM. So you can allocate some of your SD card memory. You don't have to allocate the whole memory. You can just allocate some of the SD card memory, like 4 GB or 6 GB of your SD card memory, and you can serve that as swap memory. So swap memory means it will once the inbuilt RAM is full, it will write the data. It will write data to the swap memory. So it will never the system will never exist because of out of memory error. So the NVIDIA Jetpack is a Linux-based OS. It's a Linux OS, Linux-based Debian OS. So you can use any kind of Linux commands, and if you are familiar with the Linux, you can easily use Jetpack OS. And then flash. So this is a procedure. Flash configured image with the HF program. So from a Windows, Mac, Linux PC, you can use any kind of PC to write the OS. You can also flash Jetpack from NVIDIA SDK manager. Insert the SD card into slot. So you can see the slot here. This is a slot SD card slot, and Then connect keyboard, mouse, and display. Board will automatically boot and when the power supply. So green LED will indicate power supply. So a green LED. Here in this board, you can see. So you can see the green LED here. So this green LED is indicating power supply, and I'm using a USB C type USB C type adapter to charge adapter to power the board. So then power supply, so like different options for power supply, like we already discussed here. So in case of Jetson Nano board, we have three options for power supply: power jack, micro USB, or power over Ethernet. Power over Ethernet. So like 5 volt 2 amps micro USB charger. So this is like an example of you can just go and search this, and this is an example of what type of adapter you can use. You don't have to use the exact type here. You can use any kind of 5 volt 2 amps micro USB charger. Then barrel jack you may not use the exact same thing because other type of barrel jacks may not be quality for the board. Like if you're connecting like simple basic type of hardware like different type of modules, then you can use a normal DC to AC to DC adapters. So but here this board needs specifically 5 volt 4 amps DC barrel jacks. This is hard to get. This is like normally all the AC to DC adapters are in the 2 amps or 1 amps range. So it is better to use the specific one that is mentioned here. So you have to place a jumper on the header J48 to use the barrel jack. Otherwise, you cannot use the barrel jack. You cannot use the USB power, micro USB power. And J for expansion header. So you can another option. So we have 4 options here. So we have all these expansion. We have the expansion header and all these pins here, including all GPIO pins and GPIO pins, and also other special purpose pins like VCC, VCC ground, all those pins. So using those pins, we can power up the board. In case if you don't have a like a connection for you don't have the resources to connect to a USB or barrel jack. In that case, you need a power bank or a direct power supply. So if you are using like in a wireless case, you have to, if you are using a power supply and you're powering the board through the power supply, not through a power bank or adapter. Then in that case, you can use the expansion header and you can power the board using expansion header. So it should be up to 5 volt and then 3 amps. Then power over Ethernet PoE, standard PoE supplies 48 volt. Then use a PoE hat or 5 volt regulator. So you have to use a PoE hat power over Ethernet hat to power up using Ethernet. Then J40 button header can disable auto power on. The button header is used to go. And then we will see all the different types of connectivity. Like here, that in case if you're connecting a cooling system, you can connect the fan here and here, and so that will automatically turn on and turn off the CPU based on the CPU temperature. It will turn on and turn off. Then camera connector, button headers, serial port headers, and into a key slot, expansion headers, SOD and connector, fan headers, Ethernet jack, then USB headers, USB connectors. So then, so this is. So then the GPA, the expansion header here, what are the specific pins in that expansion header? So like any other, so if you like any other microcontroller, all these pins, like microcontrollers. So this is not a microcontroller. It's a single board computer, but still like microcontrollers, it has expansion header and number of pins. So in this case, it has 40 pins. And most of these pins can be used as GPIO pins. So whatever pins that's the GPIO, you can use this as GPIO, general purpose input output. You can configure it as input or output, and you can use it as in basic input output operations. Otherwise, you can use it in special purpose, like if you want to use I2S or if you want to use SPA protocol, you can use these pins. And if you want to use I2C protocol, you can use these two pins. And two I2Cs are available, two SPAs are available. SPAs are available in case of Jetson Nano. Then other kind of camera interfacing pins and audio interfacing pins. So this is a pin header here. Similar 40 pin header to RPI like Raspberry Pi. Similar 40 pin header like in Raspberry Pi or 3.3 volt logic level. So the logic level is 3.3 volt. ADA, Blinka, Seed Studio will support. And you can use a Jetson GPIO Python library compatible with the API, compatible API with the RPI.GPIO. So RPI.GPIO is a library used for Raspberry Pi GPIO configuration and GPIO programming. So that same library can be used here for Jetson Nano and doors and samples you can find here in Jetson GPIO. Then sysfs. So using sysfs, you can access and configure the GPIO using this sys class GPIO. So this is one example of hardware abstraction. Here we talked about hardware abstraction yesterday when we were talking about ROS. So in case of any kind of system, so this is how in Linux systems the hardware we can access hardware elements. So the hardware is we can access hardware as a virtual file like this. So if the file is saved in sys class GPIO, so in that file we can just change different configurations and you can use the GPIO pin. So you can access this virtual file here for configuring the hardware, GPIO hardware pin. So you can just mention it, so this is for map the GPIO pin, for mapping the GPIO pin. So to say that we are going to use the GPIO pin 38. So just write like this. So you can just run the command echo 38 sys class GPIO export. Then echo out configure the pin 38 as output. And then make the pin high. And then again unexport, remove the pin. And so then cat debug GPIO query status to see the status of the pin, like set the value. So this is just basic type of GPIO configuration through system files. Then C++ programs can use the same sysfs files. So then, so this is all about Jetson Nano. So that is the main processor. So we need a main brain for the robot system. So we can use Jetson Nano as the main processing unit. And then for small controlling purposes, we can use controllers. So we can use so mostly one of the most famous platforms when it comes to this type of development. Prototyping is Arduino. With Arduino, prototyping is very easy. Like if we take any other type of microcontroller platforms, it will take more time to develop any type of applications, high-end applications, for like by using different type of modules and sensors. Because with Arduino, everything is already developed, and you can easily add the library, include the library in your code, and you can easily make things happen. So that it's for easy to prototype and easy to use. And there are like so many different varieties of Arduino boards out there. You don't have to use Arduino exactly. So in my project, in my case, I use in the Slam project, I used Jetson Arduino Nano for controlling microcontroller, and Jetson Nano 4GB variant is used for other processing purposes. So here, so I'm not going to discuss about Arduino here. We'll just directly go to Jetson Nano. So here I'll just share my screen. So here I need to we need to connect to the Jetson Nano. So like I said, I'm using this board here, and it has that Wi-Fi dongle connected here. So it is connected to the Wi-Fi network that my laptop is connected. My laptop and Jetson and both are connected to the same common network. So that means I can use IP to access the Jetson network. So I can either use the USB jack here, in that case, I don't need the network. I can just directly connect a USB cable and you can access using some kind of software like Qt software here. So I can just show you a okay, this is not USB, it's not detecting. It's not detecting because the cable is in data cable, and I think it's power cable. So that is. If we have a data cable, right now we can easily connect it using the phone. So like if you don't have that, then we have Ethernet connectivity. You can just use the LAN cable and you can connect one end of the LAN here and other end on your laptop. And then you can use the use like local IP, local host IP to connect to the Jetson. So I can use like Qt here. So first of all, I need to find out the Jetson is also connected to the same network. So I'm connected to this network called Panda. Jetson is also connected to the same network. So I need to find out the IP address of Jetson Nano. For that, I am using this IP scanner application called Fing, F-I-N-G. So it's available in Android and Windows. So you can I'm using it in Windows and scanning devices. So we can use this network scanner to see all the devices connected to the network. So in my case, my laptop is connected to Panda Guest and all the devices connected to the same network. I can see all the devices connected to the network. And if you want to make sure that Ubuntu Jetson is connected, you can just press refresh. And you can see here Ubuntu desktop. So I named it Ubuntu desktop. Ubuntu desktop. It's short. It says Windows, but it's not right. It's just it's a Ubuntu system. It's not a Windows system. And we need the IP address. IP address here 192.168.120. So this is IP address. I can access I can either access full desktop view or I can just access a terminal. To access terminal, I can just use this software called Qt and just type the IP address, and it is called SSH connection. SSH connection. SSH means we can only access that once the terminal view and you accept. Then you have to log in here. So this is a terminal view, just an terminal view. So initially I have to log in. So in my case, the desktop is called Ubuntu and the password is also Ubuntu. So now I'm going to log in. So you can see Ubuntu desktop. So this is the terminal. Here I can just start type different type of so this is home directory. I'm in home directory right now. So here I can type different type of Linux commands to see the files. Like I can type ls command to see all the folders and files. So these are the desktop folders. Like in any other normal system. So if you open Windows File Explorer, in the home page we can see all these different things like desktop, documents, downloads, and whatever files we have saved. So this is the same thing here. I'm using that. So if you want to run like run any kind of other commands, you can run it directly from terminal itself like this. So this is one option we have. We can use Qt software and run it from terminal. Otherwise, you can use VNC. So VNC viewer, you can use VNC viewer here. So VNC Viewer is a remote desktop application. To get the full desktop view, we can use this and type the same IP address. So it will ask for password. Password is Ubuntu. So just give remember password. Okay. So right now it is we are connected. So right now we can see this is a desktop view. This is the Ubuntu desktop. Jetpack desktop. So this is not Ubuntu like Jetpack desktop view, and like any other Linux system, it has terminal and all the connectivities, file system, everything is the same. And accessories, you can see system tools, LX terminal, and run commands. You can use LX terminal. So here we need to install all the different packages. Like for example, if you want to install a particular Python package, then you have to first install pip. So pip is a package installer. It is used for installing different type of libraries for Python. So if you want to install Python 3, you can use command pip3. So pip3 sudo means super user do. So pip3 install. So the library that you want to install. So if you want to install OpenCV, then you can just type OpenCV Python. That will install OpenCV. In my case, it is already installed, so I will just say recommend already satisfied. So like that, if you want to install any kind of package, for example, I want to access the camera from here. So I want to install FS webcam, or I want to install this package for the LUVC. Using that, I can access the camera. I can install that using sudo apt get install LUVC view. The package is available. Then you can. So these are not available in this case, I think. We can, if it says like this, you can also again try one more option. You can just update the index list. So when you code apt-get, it will just go to this index that is already available in OS. Then it will check inside the index file. It will check for any kind of it will check for the particular package that we want to install, and with that package there will be the URL URL to access the files for that package. And this one is actually updating. The update option is updating that list, so all the new URLs will be added. Then afterwards you can install. Still, if you're not getting it, that means it is not available for the particular OS that we're using. So we can try to install some other package. So FS webcam is available. So it's so that means we can install it. So it's installing the FS webcam. FS webcam. And then I'm just going to connect the camera to the module. Then I can use the command FS webcam. The indoor JPG command to capture image. So it's captured the image and it saved us indoor JPG. So I can just, we can see that file here in home. So it's saved to home here. So it's just the image of Jetson and not very clear because the file is not focused. So it's the image of Jetson and that I've just seen this. So this is. Then you can run different packages using terminal here. So I'll show you a demo. So I'm not going to run directly from Jetson here because there is some problem with the packages. We have everything we need to have installed here, but still there is some problem because it is not properly installed. This OS is actually newly configured with the new OS that installed all the packages. But still there is some pending packages. I've installed OpenCV, Core, PyTorch, Matplotlib, all these libraries. But there are some packages missing, so we cannot directly run it using. So if we run, everything else will work. So this is real-time object detection program. So this is a real-time object detection program. This is used to, so this object detection program uses mobile net SSD algorithm. So it's a neural network based deep learning algorithm. Mobile is one algorithm and SSD is another algorithm. So SSD means single shot detector. So mobile net is this particular algorithm is used for any kind of mobile objects, like any kind of moving objects can be detected accurately using mobile and SSD. And it's a very compact algorithm. That means you can run it in low-end hardware like Raspberry Pi or Jetson board that we have here. And so this here, I can run this here connected. So it's loading everything. And so there is an exception. Sorry, I didn't connect the exception was that the camera wasn't connected, so we'll just connect the camera. So just run, will run again. It detected something. That's why it's showing this coordinate, these values, X and Y values. So X and Y is the location of that object. Detected something, but segmentation for all down CV shows us. So this is the IM show is a module to show the current frame. So like while we are running the program, we can see the live video stream. We can see the live video stream and we can see the bounding box, all those things. So IM show is a module to is a module, not a module, it's a method inside CV2. So CV2 is the OpenCV library. So inside CV2, there is a method called IM show. IM show is for showing a frame, displaying a frame. So that right now I've installed OpenCV, Contrib and OpenCV, but it's saying you need some extra packages like libjtk and pkg config. And then I have to rerun the first I have to uninstall the OpenCV, Contrib and OpenCV libraries. Then I have to install this. Then again I have to rerun the installation. Then I can then I can use the IM show file. So right now it is saying there's some error because the package is not fully installed. But I can easily run this in my Windows system. I can use Anaconda software and I can run Anaconda terminal and I can run it. So I'll just connect the camera to my laptop and I can run using Anaconda prompt. First of all, we need the in the directory of a project. So I'm using. So I'm going to run this YOLO V5 program. YOLO is another deep learning algorithm that is most popular these days. We have like so many different versions. YOLO V5 is an older version. There are new versions of YOLO is also available. So we need to run the train. You can run train program, but I can run the train program in the system because it doesn't have the kind of capability to run. You need GPU, need like 16 GB or 8 GB GPU system. So we can use Google Cloud or AWS to train. We don't need to have an actual hardware system. Train and then detect. Once you train, it will create models. So you can see the models here. Train inside train, it will create a model like this. So these are like this is one example. We can show another example. So this is one example. So we'll see this example, this particular example here. So this is a training. I created this for an inventory management system, like in case of a supermarket, like we can use this type of system. So this is, or you can use a smart, like at your home, you can use the system. So this is here in this case, it is we have two different category of things here. One first category is fruits, and second category is different type of products. The products can be bathing with soap or surf excel, apple. So apple and orange and grape and all those different things. And also in that fruits itself, we have two categories: rotten and fresh. So we can detect all that. And this is just indicating all the different matrices of the trained model. And the weights is saved in the last model. The weights is the saved in weights folder. And this is the best.pt. The best.pt means the best training model. So the training always in any kind of algorithm, machine learning or deep learning, the training will go through number of epochs. So epoch is one training loop, and normal cases will run like multiple epochs, like depending on the system and depending on the data set you have, you may have run 100 times or 200 times for 100 epochs or 200 epochs. So in that, we need to say the best one. We need to say the best model. So this is the best for PT will be the best model. This is how the things are arranged. Then once we run the program, we can see the output here in detect. So it will be saved as a video in cases here. There's a It's detecting different things here. I can show you a live demo right now. So we have to change the folder here. So I need to go to your Wi-Fi master. So change directory and paste the path there. Then, so this is in base environment. So we need to connect to a custom environment so that is activate. We can use conda command conda activate to activate the environment. I'm using this environment called custom. So custom is activated now. So all the packages are installed in custom. So if I try to run here in base, it will or error. So then I need to run the program. To run the program, we need the command. So it is not we have to pass some arguments. It is not like simple in normal case. If you run a Python script, you can just run a Python. So if I want to run detect.py, I can just say detect.py and try to run the program. But in that case, it will throw error because there are some we have to add some give some input value. So this is not throwing error actually. It just didn't do anything because there was no we didn't mention any of our parameters like what object that we need to detect and what model it should be using. So we need to mention it should use this particular model in this saved in this way it's forward. We need to mention that. To do that, we need to give the specific command. So you can just give the command here. Source is 0 because we are using camera. Then wait. For that, we have to just add this here. So then slash best dot best best dot pt. So then now we can just run the program. So this will take some time to initiate. Initially it will take some time. It's not, we're not able to access camera because this software is accessing camera. Camera app is accessing camera, so we can access the camera. We close that and run the program. So this is a model summary. Like it has been 213 layers. So we talked about like input layer, not hidden layer and output layer. It has, so in that case, so this model has 213 layers and like this many parameters. This comes around like 70 lakhs. So right now the program started running and there is nothing, so it's not detecting anything. So I'll just show some objects. So I have so first of all, before training, like in case of that, like in case of deep learning, you have to prepare the data set. So there is like a minimum amount of preparation you have to do. So the preparation is annotation. So you can use different tools for annotation. So I use this online tool, website called RoboFlow for creating my own data sets. So we can just use these images as input. So there is some wrong detections are there because it's moving. So it says this one is detecting correct properly. Red and orange. So you can see the accuracy value there, 0.8. So if I move it away, you can see it's showing some other object and the value is very low. Threshold value is very low. So, but here if it is detecting properly, you can see the value is increasing. So the fresh apple, you can see fresh apple means value is high, 0.8, 0.7. So fresh apple again. So rotten apple. So this is like apple itself. We have two classes: rotten apple and fresh apple. If I hold closer, it will detect. Then the fresh bananas. So you don't have to we don't have to actually accept all these outputs. We can set threshold based on the accuracy, the value here. So if the value is less than particular, like less than 0.7 or less than 70%, then that is not the object that we want to detect. But if it is more than that, then it's accurate. So you can see whenever it is more than 70, you can see it is properly detecting, and it's only detecting that one thing. So whenever it is less than that, you can see it says up here because it's a wrong detection. And then I can just use some other image. So rotten banana, we haven't tried this. So if I can we go closer, it will detect more. Has to focus a little bit. So you can rectify so much of these problems with adding more and more data set and training again or increasing the number of epochs. By doing all that, you can increase the accuracy here. So like products, in case of products, it will detect suffix packages. So this one is perfectly detecting. You can see it's above 7.7, so that means it's a good detection and it's working. So this is like a small example of deep learning. So using YOLO V5 algorithm, how we can implement object detection using YOLO V5 algorithm. Like I'm running here using Anaconda, so we can like use this type of applications like deep learning applications in or to make our different type of property projects. So thank you everyone. Our time is over, so we have to wind up the class here. So thank you for the so on behalf of Panic Learning and myself. So thank you for listening. So I hope it was useful for you guys today's session that I do. So you can use this knowledge, and we haven't gone through that much of practical things. So you can use this as a start and try to explore yourself. So thank you guys. Thanks everyone for listening.